Hello, welcome. Here in this video, you will learn how to estimate simple linear regression model in RStudio. Simple linear regression helps us model the relationship between two numeric variables, not their linear associations but causal interactions. Suppose, for example, we want to predict economic growth that's proxied by the natural logarithm of gross domestic product using inflation, which is also proxied by the natural logarithm of consumer price index. What we actually would do is estimate the following model that's given by the ln of GDP, that's given by the natural logarithm of gross domestic product, which is equal to alpha, which is the constant, that is the model intercept, plus beta times the natural logarithm of consumer price index plus UT plus U. In this specification, land GDP is the outcome variable, that is a dependent variable, and land consumer price index is the predictor variable that is used to predict the value of land GDP. And U is the usual error term, which represents as unobserved factors affecting the dependent variable, that is economic growth in our case. And alpha is the intercept with the value of the dependent variable, that is the value of GDP when inflation is zero. And beta, that is the slope of the model, measures the effect of inflation on economic growth. In the next, we will be estimating this model in RStudio using hypothetical data or both variables. Let's begin. We are using our dataset that's named macro. That you can see the environment here. We have 44 observations of 3 variables. So to list the names of the variables that are contained in our dataset, you may use this command, that's names. This command lists us the names of the variables that are included in our dataset. Then names within the bracket, the name of our dataset, that is macro. As you can see on the R console, we have 3 names listed from our dataset. And of course, the first one is the time variable, that is a year. The variables were observed on a yearly basis. And actually, the variables that we are looking for are these two. The first one, that's the line of GDP, is the proxy for economic growth. And the second one is the line of consumer price index, which is the proxy for inflation. So the objective here is to predict economic growth using inflation. In other words, to estimate the effect of inflation on economic growth. Before we can start, we need to check the two variables exhibit meaningful correlation. And this can be done by using the Pearson's correlation coefficients using this command, that's core. And then the bracket, we can mention both variables. The first variable that we are looking for is ln of gross domestic product, and the second one is natural logarithm of consumer price index. As you can see on the R console, the estimated correlation coefficient between the two variables is about 0.8457816, which is positive and very large, meaning that the variables exhibit positive and strong linear association. That is the most condition to estimate the relationship between the two variables. So by now you can estimate the simple linear regression model fits the simple linear regression model using the lm command. Once confirmed that the variables exhibit meaningful linear association, it is important to estimate the cause-effect relationship between the two. So now to fit the linear regression model using our hypothetical data, we'll be using the lm command. Let our results be saved in the object called give any name ABC. That can be which is any arbitrary name within which our results are to be saved. So ABC, then use the lm command, that is to mean the linear model, then the bracket, predict economic growth using inflation. That's predict ln of GDP using ln of consumer price index. Now here you can see the object ABC in the R environment, which contains the estimated results from our model. The estimated results from our model are stored under these objects. So after fitting this model, use this command to see the results. Summary, within the bracket, type the name of the object. That is the object for the result of the model, that is ABC. Now the first component of the results reported is residuals. The minimum value in the list of residuals is minus 0.41909. The first quartile is this one. The median is this one, third quartile, and the maximum value for the residual is 0.32499. And next, we can see the estimated results for the model parameters. In the first case, the estimated coefficient for the intercept, that is alpha, is 4.92587 with the standard error of 0.08733 and the t-value that is very large, which is reported to be 56.4, and the probability value, which is reported in terms of scientific notation, is close to zero. Is close to zero, which means 2 times e to the power of minus 16 is almost zero in terms of decimal notation. This intercept represents the value of the dependent variable, that is the natural logarithm of gross domestic product when the value of inflation is zero. Similarly, the estimated result for the model slope, that is a beta parameter, is 0.25524, which is positive, and its t statistic is very large also. That's reported to be 11.43, and its corresponding probability value is almost zero. The estimated value for the slope, that is 0.25524, implies the existence of positive relationship between inflation and economic growth, and that relationship is statistically very, very significant because the reported probability value is zero, which is less than the conventional 5% critical for statistical significance. Therefore, inflation exerts a statistically significant effect on economic growth. And because both variables were given in terms of natural logarithms, this estimated slope parameter can be interpreted as elasticity. Therefore, 1% increase in the rate of inflation increases economic growth by about 0.26%. Next to the estimated coefficients, you have here significance curves, and the three stars indicate statistical significance at 0%. Another important element reported is residual standard error, which is 0.2205 on 52 degrees of freedom. Because we have 54 observations with 2 coefficients estimated, then 54 minus 2 gives 52 degrees of freedom. And another important element in the results is multiple R squared, that is about 72%, suggesting that about 72% of the variation in the economic growth is being explained by inflation. Literally, the coefficient of determination makes only a little importance in the case of simple regression models because the number of regress are included in the model is only one. Next to the estimated coefficient of determination, we have also the F statistic, and then the most important here is its corresponding probability value, which is almost zero. So this probability value corresponding to the F statistic is used to test the hypothesis that all of the slope parameters are zero. Unfortunately, we have only one slope parameter in the model. So again, this statistics makes only a little importance in the case of a simple linear regression model. And also importantly, you can generate the confidence interval associated with our model using this command, that is conf int in the bracket the object for our results, that is ABC. So you can see here the confidence intervals associated with the intercept and the slope parameter. Both are given at the lower bound of 2.5% and the upper bound of 97.5%. Thank you very much.